Hello everyone. Today I'm excited to introduce you to the Apache Hadoop, an open source project revolutionizing the world of big data analytics. Initially founded by Yahoo in 2006, it has grown into a powerful ecosystem for handling various big data projects. Our journey will take us through the technical architecture and the components of Hadoop, highlighting the phases of typically Apache and Hadoop projects. The components of Apache Hadoop. Let's start with the core components of Apache Hadoop. The Hadoop distillation file system, that is HDFS, it facilitates data storage in a configurable block size, ensuring the data reliability and fault tolerance through the data replication. And MapReduce, this component provides distributed data processing clusters, enabling parallel processing and accelerating the data analysis. And YARN, that means it is at another resource negotiator. YARN manages resources in the Hadoop cluster, ensuring optimal allocation for the applications deployed on the cluster. And fourth one is common utilities. These tools support application development and management, simplifying the development process. And the phases of an alpha are like Apache Hadoop project. An Apache Hadoop project typically involves the following phases. Those are ingestion of data, and this data from the diverse sources and formats flows into the data lake. We will explore how tools like Apache Kafka and Apache Flume handle vast volumes of data with a high velocity and accuracy. And next one is the processing of data. Next, we'll dive into the how data is transforming into splits and MapReduce job scheduling, assigning them to mapper nodes, allowing for parallel processing. We will see the role of Apache Pig in the MapReduce phase and the shuffling and sorting. In this phase, we'll learn about the sorting of a grouping of keys and values in the prepare them for reducer nodes. Apache OZ and Apache Airflow helps manage the data transfer process and aggregation of data. The insights delivered for the previous phases are combined in this step, including statistical operations like sum, average, and deviations. We will see how Apache Flume facilitates data volume reduction and how visualization tools like Apache Superset and Apache Zeppelin provides a clear understanding of the data. In this integration of data, now let's dive into the data ingestion phase. Like this means ingestion of the data. Data arrives from various sources such as the database, file systems, and sensors. Ensuring efficient handling of large volumes of data at a high velocities while maintaining accuracy is very crucial. Apache Kafka and Apache Flume are powerful tools that excels in ingesting the data, making it ready for further processing in the Hadoop pipeline. A processing of the data. As we move forward, the data processing phase awaits us. We'll witness how data is split and processed based on the project objectives. The MapReduce paradigm and the use of Apache Pig contributed to the success of this phase. By leveraging parallel processing, Hadoop optimizes data analysis, enabling faster results. And shuffling and sorting. Now we reach the shuffling and sorting phase. The process involves preparing data for reducer nodes by sorting and grouping keys or values. Data transfer is intensified during this stage. Partitioning helps identifying the appropriate reducer nodes, while sorting at the reducer nodes facilitates organizations and efficient data processing. Apache Uzi and Apache Airflow play a vital roles in managing data flow and take coordination during this phase. Aggregation of data. Our final technical phase focuses on data aggregation. Insights obtaining from previous stages are combined to produce more meaningful results. Data volume reduction enhances the efficiency of specific analytics. Apache Flume assists in this reduction process. Additionally, statistical operations are performed, such as sum, averaging, and deviations. The visualization tools like APCHA Superset and APCHA Zipline provides interactive representations of the data, aiding in the comprehensive of the insight. Outputting of the data. The final phase in this technical process is the outputting of the data. Activities such as reporting, visualization, and concluding stages of analytics take place here. Findings are drawn, and business intelligence skills may be employed to enhance the accuracy of results. The data can be stored in the Hadoop distributed file system, that is HDFS, for future references and enabling easy access and retrieval. Apache Zipline is a powerful tool that can assist in this phase, providing a collaborative platform for data exploration, visualization, and reporting. This is the Hadoop ecosystem. The Hadoop ecosystem is a collection of open source software tools that are used to store and process large amounts of data. The Hadoop ecosystem is a rapidly growing ecosystem, and there are a number of new tools and technologies being developed at all the time. The components of a Hadoop ecosystem, the main components of a Hadoop ecosystem consists of a number of different components, including Hadoop distributed file system (HDFS), a distributed file system that stores data on a cluster of machines, and a MapReduce, a programming module that is used to process the data in Hadoop, and Yarn, the resource managing framework for Hadoop, Hive, SQL like language for querying data in Hadoop, and Pig, high level language for processing data in Hadoop, and HBase, no NoSQL database that use it to store large amounts of semi-structured data in Hadoop. Spark, that is a fast and scalable general purpose cluster compounding system, and Zookeepers, distributed coordination service for Hadoop. And the conclusion that I'm giving is the Hadoop ecosystem is a powerful tool for storing and processing large amount of data. The Hadoop ecosystem is rapidly growing ecosystem, and there are a number of new tools and technologies being developed all the time. Thank you for your time. I hope this presentation has given you better understanding of the Hadoop. Thank you.